Welcome back to my channel. The chapter is coordinate geometry for standard 10 and this is part 2. So in the previous part I have given you all the formulas related to this chapter. So now we will do the questions based on that. Now here two points are given. You have to find the distance between the points. So I'll put this as A and B. You know the distance AB is equal to root of x1 minus x2 the whole squared plus y1 minus y2 the whole squared. It's only the difference between the x coordinates square plus difference between the y coordinates square. So here it is minus 6 minus minus 1 the whole squared plus 7 minus 5 the whole squared. So this will become 1, this will become plus plus. So minus 5 the whole squared will become 25 plus 4 equal to root 29 units. The next question is A sin alpha minus B cos alpha and minus A cos alpha B sin alpha. Let the points be PQ. So the distance PQ is equal to root of A sin alpha minus A cos alpha the whole squared plus B sin alpha minus B cos alpha. I am writing like x2 minus x1 here, y2 minus y1, so that our calculation becomes easier. So this will become plus. Now here don't expand it, a plus b the whole square, don't do that. Now A sin alpha plus A cos alpha, you have A as common. So A into, then that square also is there. So we will take A squared out and then write sin alpha plus cos alpha the whole square. The same way here also, the second term also, we will take B is common. So it is inside the square, so it is B squared into sin alpha minus cos alpha, plus the whole squared. Now sin alpha plus cos alpha is common. Sin alpha plus cos alpha the whole squared, then A squared plus B squared. So this is equal to, we can take sin alpha plus cos alpha out into root of A squared plus B squared units. The next question is prove that the points are vertices of a square. Now the 4 vertices are given. Now we have to prove it is a square. Before we start this, I will give you some hints how to go about these type of problems. Now to prove that the given quadrilateral is a parallelogram, you know in parallelogram the opposite sides are parallel and equal, but here we cannot, right now we cannot prove it is parallel. We are dealing only with the distance. So we can prove if both the pairs of opposite sides are equal, then we can say it's a parallelogram. Therefore AB is equal to CD, that is this AB equal to CD, and then BC equal to CD, we can prove this and this. So then you can say it is a parallelogram. To prove it is a square, you know in square all the 4 sides are equal. So that is what you are going to prove here. AB equal to BC equal to CD equal to AD, using distance formula all the 4 sides are equal. Along with that, because in rhombus also all the 4 sides are equal, but now you have to differentiate between square and rhombus. So in a square, you know the properties of square, rhombus, everything which you have learned again in 8th standard, 9th standard. In square the diagonals are equal, in rhombus the diagonals are not equal. So along with the sides you will also prove the diagonals AC equal to BD, then you can say it is a square. So all the 4 sides are equal, the diagonals are equal, then it is a square. To prove it is a rhombus, you have to prove all the 4 sides and then prove the diagonals are not equal, then it becomes a rhombus. So it's square, rhombus, parallelogram. Now comes to rectangle. In rectangle, opposite sides are equal. Along with that, if opposite sides are equal, it can be a parallelogram also. So to differentiate between the parallelogram and a rectangle, we have to prove the diagonals. In a rectangle, the diagonals are equal. So AC equal to BD, if you prove, you can say the it is a rectangle. If you prove only the sides, opposite sides are equal, then we say it is a parallelogram. Now to prove it is the 3 coordinates given are triangle. If AB plus BC is greater than AC, BC plus AC greater than AB, and AB plus AC greater than AB, then we can say it is a triangle. That also we have learned in lower classes. Sum of 2 sides of a triangle should be always greater than the third side. It cannot be even equal to, it should be always greater than the third side. Now to prove it is a right triangle, you will find the length of all the 3 sides and then check for AB squared plus BC squared equal to AC squared. The sum of the squares of 2 sides is equal to the square of the third side, then you can say it is a right triangle. For isosceles right triangle, find the sides, then you will find if 2 sides are equal, then it is isosceles. Then you have to prove it is a right triangle also. So again, square of the sum of the squares of the 2 sides is equal to the square of the third side, then it becomes a right triangle. So we will come back to our problem here. The points are of a quadrilateral are given. You have to prove it is square. Now we will find the length of AB. We will do it fast. So 4 minus AB, 4 minus 1 the whole square, plus 2 minus minus 1 the whole square. So 3, 9, I will write 9 plus again 3 a square 9. 2 minus minus 1. So it is 1742 minus 1 minus 1 minus 4 4, yeah. So 1 minus 4 minus 1 is fine. So 7 minus 2 or 2 minus 7. So it is not 9, 25. So it is 34. BC root of 4 minus minus 1 the whole squared plus 2 minus minus 1 the whole squared. Write the answer, do it mentally and write. For 4 plus 1 5 squared is 25 plus 2 plus 1 3 9. So it is root 34. Then CD root of minus 4 minus minus 1 the whole squared plus 4 minus minus 1 the whole squared. So minus 4 plus 1. So minus 3 the whole squared will become 9 plus 4 plus 1 5 25. So root 34. Now AD root of 1 minus minus 4 the whole squared, 7 minus 4 the whole squared. So 25 plus 7 minus 4 is 3, 9 equal to root 34. Now you saw, you can see all the 4 sides are equal. Now we have to prove AC and BD. So AC is equal to root of 1 minus minus 1 the whole squared plus 7 minus minus 1 the whole squared. So 1 minus minus 1 will become 2, 4 plus this will become 8, 64. equal to 68. Now BD will be 4 minus 4 the whole squared plus 2 minus 4 the whole squared. So again it is 864 plus 2 minus 4 is minus 2, square is 4, equal to root 20, 68. Okay. 4 minus 4 the whole squared, 2 minus 4 the whole squared, equal to 64 plus 4. So you can say all the sides are equal, diagonals are equal, therefore it is a square. ABCD is a square. Now check whether the points are collinear. So the collinear points means the points which lie on the same line are called collinear points. So here let me put this as A, B, C. We will find the distance. To prove collinear, one of the method is using the distance formula. We will find the distance AB. AB equal to root of 0 minus minus 2 the whole square plus 5 minus 1 the whole squared. So this will be root of 4 plus 16 equal to root 20. So I will write this root 20 as 4 into 5, it will become 2 root 5. Then BC equal to 0 minus 2 the whole squared plus 1 minus minus 3 the whole squared, 4 plus 16 equal to again root 20 is 2 root 5. Now I will find AC, root of minus 2 the whole squared plus 5 minus minus 3 the whole squared equal to root of 16, 4 square 16, 8 square 64, root 80. Root 80 can be written as root 16 into 5 is 4 root 5. Now if you see the length AB, BC and AC, you can write AB plus BC is what? 2 root 5 plus 2 root 5 equal to 4 root 5, and AC is equal to 4 root 5. So you got AB plus BC equal to AC. That is, if you draw a line like this, points AB and BC will become AC. Therefore, the points are collinear. For the points are hope you have understood. So keep practicing. Maths is just practicing only, it is not tough. It will be tough as long as you don't practice. So see you with many more problems, many more questions in my next video. So see you. Have a nice day.